I was recently talking with somebody about converting and migrating processes from the real world into AI agent workflows. A few things came up as a part of that discussion that I wanted to share to help folks maybe get better results out of AI workflows that they're using. The first one is that sometimes a large language model is not necessarily always the best tool for the job. Like with most things in engineering, you gotta use the right tool for the right job. And sometimes large language models just ain't it. For example, imagine you wanted to count the number of R's in the word strawberry. As we've seen, large language models sometimes slip on things like this. A better way to view this process might be to think of delegating this specific responsibility. In this case, it would be counting the number of target characters that occur in a specific string sequence. In this very specific case, we would of course be counting the number of R's in the word strawberry and use sort of this traditional compute tool, things that have been around for decades. Obviously, like counting the number of characters in a sequence is something that's super easy for a computer, traditional compute methods to do, but maybe a little bit more challenging for something like a large language model to do. These tasks are sometimes not necessarily the best fit for a large language model, where you need precision. You sort of need almost like a calculator level precision. However, your large language model is not super great at these objective things sometimes. It's very good at subjective things, but sometimes with objective things, it's just not the best. Now, if you were to take the output of a traditional computer program and sort of feed that back into the large language model, so in our specific case that we're talking about, that would be passing the string strawberry into this compute function that we're speaking to. And of course, it's going to count that number accurately and return 3. If you feed that back into the large language model, the output of 3, then you are going to get a much better result, because we know that's a tried and true method that's been done many times over many decades. Informing the large language model and sort of taking some of the brain work off of it, instead of having a traditional compute method compute that value, you're going to get far more accurate responses. So a more complex example may be something like you want to do a sum of all of the money spent on a very specific category of something. A large language model might be able to do this. It might even be able to delegate it out to a Python script to do that. But even the large language model itself is trying to delegate to a traditional computer program. It knows that sometimes it's not going to be able to do these things that are so seemingly basic in an efficient way. So it offloads all of that compute work to something that is far more straightforward to work with. That sort of beautifully leads me into my next point, which is sort of thinking in functions. So one of the things that you may want to do as a part of breaking down processes in your AI workflows from human processes is sort of think of everything in terms of functions. What are the inputs? What are the outputs? What's the transformation function that is acting on the inputs to get that output? If you start to think like this about human processes as well, you start to kind of see how everything breaks down into really functions. This is sort of like a computer science way of thinking of things. Think of the world in functions. And of course, this is only a conceptual framework and a tool that you can use. Sometimes things can't be subdivided. Sometimes it's unnatural to think of things as functions. In the example from before, there are 2 inputs. The first is going to be the string sequence that you want to count the occurrences of a specific character in. And then the second would be the target character that you want to count for. So that would be the string strawberry in as the input and an input of R as the character that you want to count. The transformation function in the center would be maybe a for loop in the most basic sense, where you are going to iterate over every character in the sequence and say, is this R? Is this the target character that we want to count? If it is, increment the count. If it isn't, just continue on. Then of course the output is going to be the number of times that you did the increment within that for loop, which in this case would be 3. Viewing everything as a function sort of allows us to set boundaries on the things that we are supposed to do and the things that we are not supposed to do. And it gives clear definition to the piece of data that we need and what we're expecting to get back out of those things that we are operating upon. Try to think of this in an abstract way though. I think I'm trying too closely to operate on a very specific example, but what I'm saying is more conceptually think of things as functions in the world. Start start looking at things around you and thinking about what are the inputs, what are the outputs, what's the transformation in between. This allows us to conceptualize these processes much more naturally into a large language model. At the end of the day, a large language model is of course a computer that is really just a bunch of functions. So functions are very natural for computers to operate upon. And then the last piece would be, how do you know that you have the right balance? How do you know that you've done the right work in order to convert this human process into a large language model or AI workflow? One of the simple litmus tests that I've used, sort of think of the model that you're using as a good indicator of your ability or the clarity that you've provided in your process. So what I'm trying to say is, in the case of Claude, if I were to model something out in Claude code, we could start with building our specific workflow in Opus, but then maybe try to set the model back to Sonnet. Is it able to still do the process? If it is, then chances are you've defined the process and the boundaries fairly well, and your process is able to run without interruption or issue with a less capable model. That tells me that you have clearly defined inputs, you understand your transformations, and you understand what your output is. Maybe you even go as far as pulling it back to haiku. It's the structural durability of the process as you sort of go from, let's say, a PhD level thinker to an 8th grade thinker. Were you clear enough in your process description such that the PhD level thinker and the 8th grader can sort of act the same in this process? These are some things that at least I've found value in as a part of building out processes from the real world into AI workflows, and hopefully help you guys out too.